Welcome to ClickMyProject.com. Let me discuss about the process. A fast clustering based feature subset selection algorithm for high dimensional data. Let me discuss about the abstract of the project. The aim of this project is to automatically identify the relevant cluster for microarray gene expression data sets to keep high quality systems update of newly recorded data. However, the selection of the most representative features of the strongly related target cluster is needed for the appropriate selection of subset of features. Features are divided into clusters by using graph theoretic clustering methods such as the minimum cost spanning tree clustering method, which ensures the identification of the exact cause of the immune deficiency disorder in PIDs. A modified version of vector quantization is used in flexible fuzzy inference system, specifically for Takagi Gnu fuzzy model to identify the appropriate cluster. A fast clustering based feature selection algorithm for subset selection is proposed. This strategy has high probability for producing a subset of useful and independent features specific to the PIDs. The system adopts the minimum spanning tree clustering method to ensure efficiency. It builds classifiers on the basis of the decision rules arising from these genes or gene pairs. This gained high-quality solutions to classification problems in the analysis of high-dimensional gene expression. A method is needed to select clusters, genes, and conditions simultaneously, finding distinctive clusters with less number of rules generated. Feature selection is the process of selecting a subset of relevant features for use in model construction. Here, fast algorithm is used for selection of features. In fast algorithm, clustering-based strategy is used, where the data are clustered according to the irrelevant features. Let me discuss about the flow diagram for our process. Here, the DLBCL dataset or multi-B datasets are taken from the dataset folder, and features has been extracted from the dataset folder. Feature has been extracted from genomic identification significant targets in cancer designed for analyzing chromosome abbreviation in cancer. These features has been calculated by the method calculates the static that involves both the frequency of occurrence and the amplitude of abbreviation. Second, it assesses the statistical significance of each aberration by comparing the observed statistic to the results that would be expected by chance using a permutation test that is based on the overall pattern of aberration seen across the genome. Next, the feature selection has been proposed. The fast algorithm works in two steps. In the first step, features are divided into clusters by using graph theoretic clustering methods. In the second step, the most representative feature that is strongly related to target classes is selected from each cluster to form the subset of clusters. Features in different clusters are relatively independent. Clustering based strategy of fast has a high probability of producing a subset of useful and independent features. To ensure the efficiency of the fast, the efficient minimum spanning tree clustering method is proposed. A minimum spanning tree is a spanning tree of connected undirected graph. It connects all the vertices together with the minimal total weighting of its edges. Prim's algorithm, rather than build a subgraph one edge at a time, Prim's algorithm builds a tree one vertex at a time. Finally, the cluster formation are implemented based on the Sugno fuzzy model, where A and B are fuzzy sets in the antecedent, while Z is equal to f of x comma y is a crisp function in the consequent. Usually, it is a polynomial in the input variable x and y, but it can be any function as long as it can appropriately describe the output of the model within the fuzzy region specified by the antecedents of the rule. The fuzzy inference process have been referring to so far known as Mamdani's fuzzy inference method. Most common methodology in this section are Sugno fuzzy Takagi model. Finally, the performance has been analyzed based on the selected relevant features. Let me discuss about the running procedure for our process. Select the main.m file, the control file, and run for executing this process. Here, we have to select any one dataset, either DLBCL or multi-B dataset. Here I am selecting multiple DLBCL dataset. And after selecting the dataset, we have to select corresponding label from the dataset folder. Here DLBC label are selected. After selecting the label, the process is executing. This is the Sujuno fuzzy model iteration has been run and executed. After executing the process, we obtain the performance graph. This is the input data of our selected dataset, and this is the irrelevant features removal, the removal of irrelevant features from the dataset, and this is the tree formation. And these trees are relevant information retrieved, and this is the irrelevant features tree representation. And this is the bar graph for our frequency versus features values. Here the bar graph will be plotted by varying the penalty values, and this is the corrected rate for our by varying the iteration between our proposed and existing system. Finally, we cluster the relevant and irrelevant features and analyze the performance. Thank you.